Good morning and welcome. For those of you who do not know me, my name is Steve Coffey. Very pleased to be with you and be invited back for my second chair, technical chair. And this is the second annual International Produced Water Management Conference, Africa, which is 100% virtual this year. Very excited to see many faces. Right now we have a handful of people from six different countries actually already on with us. It's been 23 months since we've actually seen each other virtually or for some of us and in person for most of us. And this group who met in Lagos back in November of 2019, we're welcoming back many of the speakers, many of the sponsors, and many of the exhibitors offering a product showcase today. So I'm very excited to see how this virtual element of this works for this very international group. Beyond Africa, we're anticipating 3 to 4 other continents joining us today. I think maybe the only one that's not represented is Australia. And if you are coming from Australia, please let me know. I would be very interested to know that. But this is definitely an international group with a focus on Africa. A lot has changed since we've last met, besides the obvious things that we've all affected our lives, like the pandemic and an oil commodity crash. There have been many positive things that I've seen that have happened and begun as we've started to rebuild the community. The produced water professionals that I know abroad and close to home, they all share this deep desire and willingness to share knowledge and to rebuild the community during this time. And I think it's important for us here to take that same ideas and the same knowledge base and the passion that these other folks have in other events that I've attended recently, and use that to kind of use it as a catalyst for change and renewing interest for produced water management in general and the environment, with an increased focus on sustainability for Africa. So I'm very excited to welcome you here today and to share with each and every person here during the networking sessions, the fireside chats, the product and company product reviews, as well as during the Q&A sessions that we will have today. Hopefully this format with using the Remo will be very interactive. Hopefully you take advantage of that. Produced water is becoming an increasingly challenging topic and job for everybody. And I think this is the perfect place to share and learn and build not only your knowledge base, but also your network. The main goals for this event are really to provide an environment for sharing innovation and ideas, and improving on what is being used currently for technologies, as well as a wide range of water management issues that stem all the way from treating to troubleshooting, debottlenecking, analyzing produced water characteristics, and evaluating and monitoring. This also is a great venue for regulators, operators, vendors, and academics, and basically anybody in the produced water community. Not only again for knowledge, but also for network, which I feel is very important. This also should provide educational materials and resources for our young attendees, which I see quite a few, and we have 2 speaking today, so I'm very excited about that. And again, like I said, this should be a catalyst for change for produced water management. So I am thrilled to be partnered again this year with Produced Water Society, which I'm currently president of, for a second time, rejoining from 2017 to 2019, and again from this summer 2021 onward for a 2-year term. We're also very pleased to be a part of the Groundwater Protection Council group and their nonprofit organization based in the US, the Society for Petroleum Engineers, and World Oil. So in addition to those folks, we are very appreciative today of all of our sponsors. They made it possible for everyone to join without any fees today. So this hopefully, big pat on the back for them for taking the step up to assist us with helping cover some of the cost to do and put on this sort of event. Those folks would include Extern Water Solutions, MySelect Technologies, Joran, Envirotech Systems, Turner Designs, Produce Water Solutions, Bullards Energy, Brevity Anderson, ExxonMobil, Seplat Petroleum Development Company, and I know I'm missing one other. Sorry, I missed my cue here, but I'll jump back in and thank everybody again one more time. But we're looking to get going here and start exploring synergies with not only these companies that I just mentioned in the year ahead, but also with everybody that's on the call right now. The delegates, the sponsors, the contributors from the 2019 event, and from this event being our first ever virtual event. And then, of course, looking forward to next year, looking forward to our Q4, most likely October of 2022, looking at our first ever hybrid event, which would definitely cast a larger net across the board. And I'm confident that that sort of hybrid offering and the relationships that we've been building with the folks that I just mentioned and the ones that are still yet to be introduced to in the year ahead, hopefully all those folks will be able to help us build a stronger produced water network and community and a better knowledge base. So we're looking forward to staying committed to adding additional services, online content in the year ahead, some webinars with some hybrid offerings, collaboration with other events. We're very keen to assist and work with other events. I've done this in the US and this has worked quite well. Collaborating with other events and societies will help us become stronger as well. I think beyond that, only thing I want to mention is we will, in preparation for that, we will next month put an official call out for papers or for abstracts for next year's events. So I encourage everyone to consider submitting the abstract before the end of the year so they can take advantage of being a part of the technical content. But today, hopefully what we want to do is just learn from each other, find out more about each other and the challenges and the opportunities that are presented to us daily with produced water management and specifically sustainability and the environment. I know many of you have, been talking about this topic for quite some time, and I definitely encourage you to share with others here in the group. But with that, I'll stop talking and welcome our next speaker, Dr. Wilson.
Thank you, Stephen. Steve Coffey. As usual, thanks for that warm welcome and creative, innovative, and wonderful presentation and opening speech. As you all know, Wilson is my name. I'm one of the executives of Reservoirs Energy. I want to especially thank you all for being with us today. This is a reflection of where we started from. Many of you who are here today were with us in 2019 when we had the first African Produced Water Conference staged in Lagos, Nigeria. Reservoirs Energy as a company has had the privilege to engage with many of you. I want to thank those that are joining us for the very first time who were not part of the 2019 event. We counted joy. Good morning, good afternoon, good evening. I mean, we have people from all over the continents of the world joining us today. It's quite early in some places, very late and very, very late in some other places. But in it all, we want to appreciate you for the time that you have created to be with us today. We want you to relax. We want you to settle down. We want you to have an open mind. We want you to engage. As a company that have devoted itself for the betterment of Africa, Reservoirs Energy, on behalf of myself and the entire board and our partners, especially the Global Produced Water Organization, headed by Steve himself, who has been very, very creative in terms of making sure that Africa has a say. We want to thank you. We want to thank you specifically to Brevity Anderson and to our sponsors, all the delegates that are here today. The essence of my own speech is to throw out a challenge, first and foremost, to all the participants from Africa. I want to challenge the government institutions to please create an enabling environment where companies can thrive. To the operating companies, especially those that are producing, we want to throw a challenge out today, and this will be evolving as we begin this session today. We want to throw the challenge to all our operators, the IOCs, the local producers, and many others that are in this space. The challenge is we want you to create more budget for produced water. And this is very important. To the OEMs, original equipment manufacturers that are engaged here today, and to those that have been part of this movement, the challenge is to be thrown out to you today to create a special package for Africa. You are fully aware that most of the other advanced nations, they have evolved, they are maturing, but Africa has the greatest and the largest potential for hydrocarbon. Forget about the green innovation that is going on across the world. I can assure you today that Africa has decades to explore hydrocarbon. We are not underestimating the transition into green energy. But because Africa didn't start on time, we have the biggest opportunity in the world to change the dynamics. And your equipment will come handy only if you can create unique packages, cost-effective packages that will be attractive to the players in the African continent. And to the folks from the academia, this challenge to you today is we want you to get more involved in research. We want you to create innovations that will attract the attention of the players in the oil and gas industry. We want more partnership with the academia. And to our friends who have created time to sponsor today's event, we want to thank you specifically. We know that gathering here today is not a showcase of, it's not an ordinary showcase. It's the gathering to enable the world to see the creativity, the innovation that has evolved within the oil and gas industry. And for all the players in the oil and gas space across Africa, the challenge is being thrown out today to you all, that the degradation, the depreciation of our environment is unacceptable. And as a continent, the event today will unveil the innovative technology that can come and solve those challenges, leveraging on all that we have learned over the years and the staging of the produced water event across all the other continents. Africa has this great opportunity today to tap into innovation. We can help save lives. We can help protect the environment. We can help clean up our environment. The time of arbitrary discharge is over, and we are fully aware that the regulation on each of the continents is greatly evolving. Africa is not an exception. Most of the regulators across Africa, they have woken up and they want a clean environment. Again, we want to let you all know that today's event is being staged free of charge to all delegates. It's not because we're a charity. It's because of our love, our passion for Africa. And for the sponsors that have stepped in to partner with us to make this a reality, you are special. And I want every one of us here today to have an open mind. You have come to the right place at the right time. In the next few hours, there will be an unveiling of new technologies. There will be an unveiling of creativity. There will be unveiling of new ideas. All I'm asking from you and the entire crew that have put this together, I'm talking of Bowles Energy, one of the small companies that have partnered with many across the continent of Africa to ensure that projects are delivered on time, environment is clean, and produced water is effectively managed. Brevity Anderson, one of the world-renowned event management company, who have put this together for your own comfort, and the Produce Water Global, headed by Steve Coffey, who have created and sacrificed time. All we will be asking you today is, friends across the industry, we want you to relax, we want you to network, and we want you to grab this opportunity with both hands. At the end of today, because this is not a talk show, we want you all to have an opportunity to say, from today's event, projects has emerged. Increased networking has emerged. And we can all be confident to say that we are contributing to save our environment in Africa. Thank you all. And we wish you a successful deliberation as we progress. Thank you.
Good morning, everyone. My name is Sibiada, and I'm particularly pleased to be here this morning. I'd like to start off by thanking the SPE and the Produced Water Society for the opportunity to speak on a subject that has become quite topical over the past couple of years. Permit me a moment to share my screen. Now, this subject is really downhole produced water disposal, and I like how Dr. Wilson has very aptly put, the subject. This is a subject that's receiving increased focus over the past couple of years, and I'll be sharing something around our experience as an independent energy company in Nigeria, and why this is an area that we've been looking into. So if we think about the reasons why this is receiving increased focus, I would say possibly they're threefold. One of the biggest reasons is that a lot of companies, particularly listed companies like ourselves and international companies, have adopted some of the UN ESG goals as part of our corporate KPIs. So things like life below water, sustainability and climate change are very topmost on the agenda of most of the listed companies, and Seplat is no exception to that. And a lot of our operations directly impact on these goals. For instance, in the case of produced water, there's a direct plug-in to the goals of clean water and life underwater, that's aquatic life. The second driver to making this quite topical is because the regulations around it have become increasingly tighter, particularly in our space, Nigeria, and indeed in Africa, just like Dr. Wilson mentioned. And thirdly is maybe a slightly more selfish reason, which is profitability. Indeed, from our experience as Seplat, we've seen that we can actually reduce cost by disposing water downhole. Historically, what we've done is to simply produce the entire liquid, that's both oil and water, to third parties, the larger oil companies with terminals, who treat it and dispose of it. This can cost anywhere between $3.50 to $7 per barrel, depending on what evacuation strategy you're using. And what we've seen is that you can actually cut down this cost by 20 to 30% by implementing downhole water disposal. For Seplat, we produce from 6 fields and currently between 40 to 45,000 barrels per day of water. That's quite a bit, and therefore you can see the great opportunity this portends for us using downhole water disposal. And so we then began to look at a strategy whereby we will be able to dispose the entire volume of produced water downhole, and also be able to come up with a basis for quality limits for water treatment. We started this journey, I'd say 4 or 5 years ago. We did a couple of core flood tests. I'll speak about that shortly. We built a liquid treatment facility, and so far we've drilled 3 water disposal wells, and I'll talk a little bit about our experience within the time. One of the opportunities that operating a brownfield gives you is that you are spoiled for choice in terms of accommodation space. These are old fields, and most of us in the independent space are used to this because the majors offload these acreages on you. So the accommodation space is there. You've produced a lot. There's space to put it in. There's probably some pressure depletion to help you. And aside that, you have so many wells that have already quit that you can, convert into injection wells. And the challenges around it is really sustaining the injectivity, which is closely tied to the water injection quality, and you will see that. The first step we took is to look at it in an integrated manner, bottoms up. First question we asked ourselves was, how do we select the reservoirs within which we would inject this water? And we came up with about 9 screening criteria, which cut across some key properties. I would say being accommodation space. We have a large enough tank to take this water. We looked at a cut of about 35, 40 million barrels, something that will take us about 5 years, at least per reservoir. We looked at reservoirs that provide a good isolation from surface and freshwater sources. That's very important. So you need to have a good sealing shales and be deep enough and far away from surface water. Of course, flow properties are key: porosity, permeability, and connectivity. And then we looked at a basket of about 15 reservoirs proximal to where we wanted to do this injection, close to our fields. And immediately 2 reservoirs stood out. They were big enough, they had the right flow properties, and they were also deep enough and had a pressure sink. We then went further to have a deeper idea of what the internal architecture of these underground tanks, if I may use that terminology, what they looked like, to be sure that the plumbing, if I may use that word, was all well connected. This picture is what we refer to as an amplitude map. The greenish and orange bits show sand quality that is good, meaning that it can flow. It's very welcome to flow. And the purple and the blue bits is the reservoir area that it's a bit shaly. Permeability is not so good. But I think the key outcome of what we could see is that for at least 70 to 80% of these tanks, if I may use that word, it's made up of pretty good quality reservoir that will be receptive to water injection. Further confirmed by the cross-section, east-west cross-section on the correlation panel, showing good sand continuity all the way from the eastern to the western part of the reservoir sands. Just to confirm, the flow capacity, we looked at the historical production. Between both tanks, they had a combined initial in-place volume for oil of 400, out of which we've produced slightly more than close to half of that volume, which has resulted in a pressure depletion of about 20%. So that means we have space, say about 200 million barrels of space, and pressure depletion, which will allow us to reduce the pressure head required to initiate and sustain injection. The other advantage was that out of the 16 wells that had produced from this reservoir, currently only 3 are active. So we have 13 idle wells that are available for conversion to injectors. The other side of it, which we looked at and I mentioned earlier, is the reservoir rock itself, having a closer look at it. The first thing you do is find out if the formation water between this reservoir rock is compatible with the water that you plan to inject to prevent any kind of permanent damage. So that was the first test. Water from all the 3 flow stations that we operate was injected, and they were found to be compatible. And then some characterization to know, what kind of reservoir are we looking at in terms of quality. And broadly, we saw two different categories of rock. One set of rock that's open secondary porosity, connected pores, so good permeability, and another kind of rock with restricted secondary porosity due to some clay elements in between the pore spaces, so lower permeability stuff. And later on, you're going to see how these two respond differently to different qualities of injected water. We carried out about 6 tests, which are listed here, but I'm only going to dwell more on number 5, which is the water quality sensitivity testing to suspended solids, because this one has the greatest impact on your injectivity. So just to highlight how the tests were carried out, we had these calls. I'll start off with these pictures. And this basically shows how the core plug looked like before water injection. And the last two show how it looked like after injection. And you can see that solids, we have some particles that have been deposited on the surface of what is referred to here as the wellbore, which is pretty much what we expect. But to go into a little bit of the highlights of these experiments, we had core plugs of different qualities. That's in situ, what we refer to as the in situ or original permeability. And then we injected produced water with different qualities or concentrations of suspended solids. So there's what we call the low concentration of produced of suspended solids, and that one has a maximum particle size of 2 microns. Another set of produced water with a maximum particle size of 5 microns, and that's what we call the medium concentration. And then there was a high concentration water with a maximum particle size of 10 microns. Overall, what we saw that we had the greatest permeability reduction in the case of low permeabilities and high suspended solid concentration. Within these reservoirs, the kind of port roads we're looking at, we have an average port road size of, say, 10 to 14 microns. And then you can imagine that we're injecting water, we're testing 3 qualities of water, particle sizes of 2 microns, 5 microns, and 10 microns. And immediately you can easily see the impact in the chart that we have on the left. In the case of low particle concentration, that's low concentration of suspended solids with 2 micron particle size, there's virtually no reduction in situ permeability, irrespective of the original permeability. So all the way from initial permeabilities of about 100 millidarcy up to 2 darcy, you don't have more than a 15% reduction in permeability. However, once we get to the range of 5 microns, which is the medium particle concentration, you see that impact begin to show up close to 40% for the lower permeabilities. And once you get to 10 microns, really, in some cases, you're losing as much as 80% of your permeability. And this is very well explained because we know that in order to, minimize the deposition of particles at the wellbore, you need to keep your particle size about 1/3 of your port road size. And if you want to prevent, having this deposition, plugging the pores within the reservoir itself, you need to keep it at 1/7. And you can imagine the kind of constraints this will impose for you in terms of filtration and all those requirements for injected water. The other connection you want to make is how this water gets into the reservoirs. Like I mentioned, we first went through our entire stock of idle wells, picked out a few in good quality portions of the reservoir. First thing you want to do is confirm the integrity, that the casing is able to provide the isolation that is needed for safety reasons. Select the right materials, and then you go into your workover, pull out the existing old tubings. Most of these wells were drilled, in the 70s. And then we put in new tubings, most of them 4.5-inch, because we're looking at to inject between 10 to 20,000 barrels per day of water. We did our perforations, putting our sand control, which is very, very key for this process. We've tried a couple of sand control options in our wells. We've done a frac and pack, we've done screens, we've done milled on the rim gravel packs as well. So far, it would appear that screens give the best performance, which is what we tend to go with now. So in the modeling, we try to model the injection process in dynamic modeling at a limit of 80% of the reservoir fracture pressure. We were able to attain that, but of course, this is on the assumption of totally clean water, since you cannot, with the current software that we have, model those effects of particulate matter. So in practice, what we found is that we typically do attain, our intended initial injection rates, but because the water that we inject, we have challenges in maintaining these specifications. So typically what we found is that the water quality that gets in, although in terms of concentration, it stays within, the limits, the particle sizes tend to hover, in the extremes between 5 to 20 microns. So over time, you begin to see this natural decline in injectivity, which, I mean, it's a well documented phenomenon. And once you catch it on time, you're able to carry out some intervention processes to restore injectivity to your well. Water quality is really a big one, like I've mentioned, because you want to, as much as possible, maintain that level of production that you've set for that well. And we've demonstrated clearly that this is impacted by the quality of the water, the suspended solids, the oil that you have within, the concentration of oil that you have within the water you're trying to inject, microbial activities, and fines migrations, which is related to the velocity of water during injection. But coming out from all this, from the experience with the wells that we have and the core flood tests, which I've shared some of the highlights, we came up with a couple of guidelines suitable for at least the reservoirs within the acreages that we're looking at. And these are used now to design the filtration and treatment systems that we have upstream. So suspended solid concentration of 5 milligrams per liter, maximum particle size of 5 microns if injecting in matrix mode, and 10 ppm. We relax it a bit if we're able to inject in fracture mode. We also find that injectivity is more easily maintained if you inject continuously rather than as a batch process, because that way you're able to keep some of those small fractures that you create within the reservoir open. Anytime you shorten, those fractures close, and it becomes more and more difficult as you continue to open and close to keep those pathways open. Surveillance is a very key part of the injection process. The reason is because you want to be able to be proactive rather than reactive in the way that you treat your reservoir. Sort of like taking vitamins and eating well to keep healthy rather than waiting till you get ill to see the doctor. So permanent downhole gauge is absolutely essential for an injection well, because it gives you an early warning signal to know when things have begun to deteriorate and says, hey, I need to do something at this point. It's really, really advantageous as well if you are able to have a continuous measurement of your water quality and your metering and control to each well, because this really helps you to troubleshoot and diagnose issues when they arrive. One of the areas that we are just beginning to look at as well is thinking about, hey, what if we could proactively, even ab initio, predict when injectivity is going to begin to drop. And I think you will hear a bit about that in a subsequent presentation. So really, downhole disposal is definitely the way to go. That has certainly been our experience. Once you do your planning properly, you select your candidate reservoirs, you have the right production practices and the operating limits. If you're operating in a brownfield, you're spoiled for choice on where to put it. It definitely checks the boxes for any energy company. It checks the boxes of being environmentally friendly. It checks your cost boxes because it does provide you, a very cost-effective way of reducing your OPEX. Very critical in this era of price volatility for oil, and it checks the boxes of, putting you within environmental regulation. So definitely, underground disposal is certainly the way to go. Thank you.
Hi, good morning, everyone. Thank you for that, Ibiada. We've got a question for you. The question, is she still on stage? Have we still got Ibiada on stage to answer this question, please? Yeah, there you are. Okay, we've got a question from Emmanuel. His question is, please throw some more light on the PW treatment process before injection. What do you try to take out of the produced water and how successful are you with that?
Thanks, Emmanuel, for the question. I mentioned we had a liquid treatment facility. So we have filtration units. We also have a couple of tanks that we use to do some decantation at first. The whole idea being that at the end of the filtration process, we should be able to take out particulate matter and also oil from, from the total volume of produced liquids. Like I mentioned, the success with that, I would say it's not 100% effective, which, like I mentioned, is the reason why we still get particulate matter of up to 20 microns within the disposed water. But it's, I would say, in terms of success, maybe 70%, 70, 80% success in getting the quality that we desire.
For that, he's got a follow-on question. How have you considered other PW disposal methods? What's your commentary on the comparison?
So historically, what we used to do, I'm speaking, in terms of from the settler perspective, was simply to transport the entire volume of liquid through the Shell pipeline. Shell treats it and it gets disposed deep offshore, which is a practice that is strongly being discouraged by the regulators, as you know. So that option, I think as we go into the future, we'll see it being penalized more and more, and people will have to look for other options. If you're producing not so much water, 1,000, 2,000 barrels, something that people do is to atomize and burn off the water, turn it into steam. It's another option that is used for when your water cut is not so high, but that's not an option for us. You can imagine 40,000 barrels. So really, this stands out as the go-to option. The reservoirs are there, idle wells are there. You're able to do this at, in a very cost-effective manner.
Hope that answers your question. We've got one more question from Dr. Adedoyi. Please, can you explain more on treatment of produced water before reinjection?
I don't know if I can go into, the details of that right now, given the time. But I think it goes through, there's a decantation process, there's a filtration process. But at the moment, we're even going through some technology testing for new technologies, novel technologies, and that those trials are ongoing. And I think probably within a year or two, somebody will be able to come back to this conference and tell you, you know, that we'll found something that works even better. But right now is filtration, cyclone, decantation. Blessing, I can't hear you.
Thank you very much for
Okay.
answering the questions, and thank you for delivering the keynote speech. It's very much appreciated that you should join us. Thank you to SPE as well for lending you to us this morning.
Thank you.
Really appreciate you. Thank you. I'm gonna call on our next speaker, which is John Udeme. I hope he's ready to go. He's got a brilliant presentation for us this morning. So John, if you'd like to join me on stage, please.
Hello.
Welcome, Udeme. I'll hand over to you. You can introduce yourself and then take it away. Thank you.
Okay, thank you, Blessing. Let me share my screen. All right. Thank you very much, Blessing. And I also join others to welcome you to this conference. Having listened to the speech by Mrs. Ibiada, my boss, I feel I should just say hello and step away, because it's really a summary of what we're trying to do at Seplat, which is being scientific about our approach to ensure optimal results. But permit me to discuss more on a small part of that overall work that we're doing within the produced water management space. So I'll be speaking on development of injectivity decline modeling tool, a case study of onshore Niger Delta produced water reinjection project. This work received contributions from Ibiada Itoto, Adeza Isa, Anita Odiete, Erome Utunedi, all from Seplat, and Musa Muhammad Martin Sikehi from Cypher Crescent. And the paper was presented at SP NICE 2021 conference, and it's also available for download at One Petro. This is just standard disclaimer, because this is actually our work, so it's not a reflection of Seplat's position as a legal entity. It's a reflection of the opinion of the authors. So in this work, so I'll take you through the business case, the key issues with the injectivity decline, our proposed model, what of the software, and a little bit on the case study that we used for model calibration. And of course, we'll share the conclusion and look ahead in terms of what we plan to do in the future regarding the software. So of course, the largest component of produced operating cost in most matured assets that are utilizing third-party evacuation is crude handling charges. And of course, as the first speaker said, there is also environmental concern with it. In most matured fields, you then have where you have significant water production, like in Seplat, where we producing close to 40,000 barrels of water. It could actually account for over half of our crude handling costs that the company is exposed to. So produced water reinjection for disposal has become a popular strategy for optimizing liquid handling costs, as well as supporting environmental responsibility. And it's important for us to be able to sustain this injection. We need to have optimal surveillance designs, optimal injection systems in place, optimal completion designs. And there have been models which have been used, and they've really been very key to measuring performance metrics and understanding best operating envelopes. And some of these models could be used together with 3D simulators in cases of water flooding to project and predict injection performance under two-phase conditions. So we know there are a few commercial packages that are available, but having reviewed them, it was important for us to develop something that is tuned to our unique operational characteristics, especially in terms of constant pressure injection. Of course, sustaining the initial level of water, as we know, is really achievable. The last speaker spoke about that. In matrix mode, even in fracture mode, apart from the limitation placed by environmental regulations, keeping these fractures open after long shortings is also a major issue. And while we acknowledge that the best way to dispose is at fracture mode, this tool that we'll develop is useful for understanding variables that are fundamentally key to operating your surface injection systems at optimal level, especially in terms of water quality requirements, as the last speaker alluded to. And as you can see from the performance of one of our injection wells, even with relatively constant injection pressure, the injectivity declined gradually over a period of time. And when we used Hall plot to look at whether this is a wellbore issue, you can see the signature of the Hall plot indicating that it's indeed a wellbore damage issue. Thus, injection wells would require intermittent stimulations, and injectivity half-life, which is the time required for the injectivity to drop by half its original value, could be used to plan interventions. What we see as the critical factor for loss of injectivity is, of course, permeability reduction, which has already been alluded to, coming from fines migration, microbial activities to the injected water. And I'm not going to talk a lot about the core flow test, because this is something the last speaker discussed in detail. But indeed, based on our core flow experiment, we were able to know some of the things that contributed to, within our own field and operational condition, contributed to a reduction in injectivity. And so we developed, based on understanding of the mechanisms for injectivity decline, models to be able to predict and estimate some of these parameters that are affected. So based on a review of several works by different authors, 4 key mechanisms have actually been identified. The deep bed filtration mechanism, which is the first stage, basically. And during this stage, accumulation reduces pore space, blocks thin pore throat, leading to permeability damage. If you plot on the right-hand side here, as you can see, if you plot impedance against dimensionless time, you would get a slope that is less than unity on a relative scale for that deep bed filtration. And as porosity tends to critical porosity, as porosity reduces and moves towards critical porosity, which makes accessibility of inflow particles drop to 0, and average pore size of external filter cake becomes far smaller than that of the rock. So during this period, that's the external filter cake development period. If you plot if you plot impedance against dimensionless time, you have a slope that is greater than unity on relative scale. So drop in injectivity is faster at this stage that was pointed out. So the third stage is where you have equilibrium. So forces cake are balanced by the erosional forces. So inflow particles deposit on the cake surface, not penetrate. So theoretically, you have a constant impedance value. And particles beyond this are then carried to the bottom of the well, where we call it rat hole. So particles accumulate within this well column, and gradually the well closes. So that's the last stage. So in addition to the mathematical model for the first three stages, which was developed by Paiva et al., we have developed a model to capture the last mechanism, which is in 4 here. And the total impedance change is actually the sum of the individual impedance for the different mechanisms. So the resulting nonlinear equation is actually solved using truss-reflective region approach to obtain estimates of key filtration parameters such as filtration coefficient, damage coefficient, critical porosity, cake permeability, which actually mirrors historical data, performance data if you are doing history match. So this just shows an overview of the software input pen. But I won't spend much time here because in terms of the user interface, it's still work in progress. But of course, the tool provides us the ability to enter information on well completion for calculation of injection head gain and sand phase properties. It also allows us to enter reservoir characteristics information such as porosity, permeability, size of the reservoir for calculation of storability and flowability for the deep bed filtration mechanism. And it provides us opportunity to enter information on the quality of the injected fluid, so we can run sensitivities to determine, the best operating envelope for our facility. And then, of course, we can also enter initial guesses of the filtration properties, which I spoke about in the equation, such as the filtration coefficient, the filter cake permeability, and all that. So in terms of our case study, we picked 2 of our wells, out of the 3 wells to carry out some kind of calibration and look at how the model will work. I'm going to be presenting results for one of the wells. So this well is a water disposal well that was completed in a reservoir with average pressure of about 4,100 with about 0.8 DASI and initial average porosity of about 21%. The completion strategy was a mill casing gravel pack on single string, and we targeted 10,000 barrels of water as injection rate, and initially we were able to attain about 75% of the target within the first year. If you want to see more on this, you can go to the full paper. The treatment facility, which I think has been discussed in the first paper, is a 3-bank 50,000 barrels facility, which provides injection water of average TSS of about 20 parts per million and 15 micron. And before that optimization, that led to a reduction of to 10 ppm, 20 is what we're looking at. So in the well performance that you can see at the bottom left here, two distinct periods can be seen. You can see from 2013 to 2016, and the second period is from 2019. The long shot in here, it's when the well wasn't injecting, and the second period started after stimulation was done on the well. So in terms of the model analysis, we added injection pressure to the plot you saw in the last slide. And you can see in the well injection and pressure profile, the pressure is relatively constant. Let me see if I can get a pointer here. So the pressure is relatively constant as the volume of water injected drops. So whole plot, which we've incorporated into the tool, indicates that this is the whole plot. It indicates that clearly this is a well-bore phenomena affecting injectivity decline. So in the history match plot here, this is coming from the tool, this history match plot. The effect of intermittent injection, which you would have noticed in the production performance plot, is removed in the treatment of time by making that time dimensionless. The three phases you can see here corresponds to the first three mechanisms I spoke about earlier. First, you see a relatively slow drop in injectivity during the deep bed filtration stage. And then you see a faster drop during the external cake phase. And of course, the steady state phase, that's this phase 3. So further on the model analysis, what we notice is that for period 1, which we estimated the injectivity half-life 0.0013 PVI, which corresponds to about 300,000 barrels of water injected. So after injecting 300,000 barrels, half of the injectivity index dropped by half. And so without intervention, prediction will continue in steady state mechanism until we can no longer take in water. When we conducted sensitivity analysis on this to just look at how the total solids concentration affects the half-life, a 5 ppm increase in TSS can lead to as much as 100% decrease in injectivity half-life. So this understanding has been key to our equipment design and optimization plan. So in conclusion, I would say that the tool is useful for quantifying the impact of water quality on injectivity. And prediction of injectivity half-life can be useful to plan short-term intervention, both for new wells as well as for existing wells. So our database of filtration parameters, which we are trying to build, will be useful in optimizing future water injection systems expansion projects. And when we're able to calibrate against core flood test data and even historical performance, we can estimate damage factor or filtration coefficient of wells with historical data, which could be useful for prediction of wells that do not have history data available. So what we see as the key limitation on this work is that we've only been able to use 2 wells, although we did carry out some form of validation with an external data. We feel that we could better produce a more robust tool if we're able to do it on quite a number of candidates within our field. And this is something that we'll definitely work on in the future. So we also believe there is an additional scope for improvement, especially in the area of numerical modeling and physics-informed neural network, because this will help us improve the accuracy of estimates of the initial condition after we have a prolonged shorting. So thank you very much. The team would like to acknowledge the board and management of CEPLAT for the approval to make this presentation. Of course, the leadership of corporate subsurface within CEPLAT, Western Asset Corporate Production, and of course, our technology partner on this work, CIFAC Recent, and the authors of work that has been referenced in the full paper. Thank you very much.
Thank you, Udeme, for delivering that presentation. Do we have any questions? Because I can't see any. Oh, okay, yes, I've got one. It says, what ppm was used? How critical is ppm of produced water to your work?
Yeah, of course, concentration of total suspended solids is very, very critical. As you can see on the sensitivity studies that was done, even a 5 ppm increase can actually, affect the injectivity decline. So back to the question of what was used, we used 20 for the initial phase, and of course in the second phase it was 10 because there was an improvement in the operating parameters for our injection facility.
Thank you. Could I ask you, Udeme, to stop sharing your screen for a second? I've got another question for you. Again from Emmanuel, it says, how are you able to achieve the required ppm?
Okay, yeah, so this also, I think, goes back to the question that the first speaker attended to. So, of course, there are several processes in the treatment of the produced water. And clearly, it's important to have the right conditions that optimize the operating system. So this is not, the treatment part is not actually my area of expertise, but I think what we've done is to, in the modeling aspect, is to provide thresholds to help them define thresholds that they have to target, which is in the processes that leads to the final water that is being injected, whether it be decantation, filtration, or whether it's settling, to whatever process they need to do leading up to the final water that will be injected. That has to be optimized.
Question, any regulatory concerns on ppm?
Yeah, so I think this has to do with, of course, disposal on surface. But of course, in terms of underground or subsurface disposal, our major concern will be compatibility with the reservoir. So in terms of what the ppm is, I think what the right ppm is for compatibility, which of course affects injectivity decline. I think the first speaker has given a bit of guidelines, and we're looking at optimizing to 5 to 10 ppm for the underground water disposal. But for surface, I think of course DPR has limits on that. But we are not disposing on surface, so that's not really our worry.
So much for that, Udeme, and I hope that answers your question, Emmanuel. I'd like to say thank you to Udeme John for presenting, and thank you to CEPLAT as well for allowing him to come today to join us. I'd like to call on Dr. Wilson to introduce the next speaker, please.
Thank you, Blessing. And a special thanks to CEPLAT. I want to appreciate both Mrs. Udeme and John Seplat is one of the pride of Africa in terms of local content and the indigenization of the oil and gas industry. We appreciate you. Thanks for the in-depth presentation in terms of your technical know-how. At the moment, you will realize we have several presentations, and the next one will be coming from ExxonMobil. We have with us here today Wisdom Patrick. He will be taking us down the route of what the regulations are, the gains and improvement opportunities that are in there for industry players. Join me all to welcome Wisdom Patrick from ExxonMobil. The floor is yours, Wisdom.
Hi, good morning, everyone. Good morning, Dr. Wilson, and everyone in the conference. My name is Dr. Wisdom Enang, an operations engineering consultant. I'm very grateful for this opportunity to be a part of this conference themed Produced Water Management in Produced Water Management and Environment Sustainability. Nigeria, as we know, has the highest production volume in Africa for crude, and as such has a strategic role in charting the course for environmental sustainability in the exploitation of oil and gas resources in the African continent. Produced water regulation in Nigeria falls under the purview of the EGASPIN, which is the environmental guidelines and standards for the petroleum industry in Nigeria. And the EGASPIN broadly are environmental safety standard that must be complied with by operators in Nigeria to prevent, minimize, and control pollution from the various aspects of the petroleum operations. And given the significance of EGASPIN in regard to enhancing environmental sustainability and good governance in the Nigerian oil sector, it is pertinent to review and assess various aspects of it in light of current knowledge and advancements in international best practices, law, governance, methodologies, and pollution control technologies. As such, in this presentation, I attempt to review the EGASPIN to determine its alignment with international best practices on environmental protection, identifying existing gaps, and as well as providing recommendations on improvements that would actually increase EGASPIN's effectiveness. This review is on the backdrop of three key matrices: stringency, which looks at how comprehensive are environmental standards laid out in the EGASPIN, especially with respect to target and intervention values; transparency, how easy it is for the public to get information on the application of a EGASPIN; and compliance, how robust are the processes and regulatory supervision arrangements in regard to enforcing compliance by operators. The primary key strength of the EGASPIN is that it sets out comparatively robust environmental standard requirements that must be met by operators during the project approval, operations, and closure or decommissioning phases. And this, of course, includes the produced water regulations. However, compared to environmental guidelines in comparator countries like the US, the UK, Norway, Canada, and a developing country like Oman, there are a number of gaps which limit the overall efficiency of a EGASPIN in terms of stringency, transparency, and compliance. This indicates that more work needs to be done to harmonize EGASPIN's target values to the local conditions. Now we take the first metrics, which is the stringency. The target values laid out, for example, in the EGASPIN are extremely high and not strict enough to deter, pollution in the way that it would like to deter it. EGASPIN defines target values as the soil quality required for sustainability or for the full restoration of soil functionality for human life animal life and plant life, while the intervention values refers to soil quality for which the functionality of the soil for human, animal, and plant life are threatened. So concentrations in excess of the intervention values correspond to serious contamination. Compared to international standard, the intervention values indicated in the gas bin are really high. For example, the maximum tolerated concentration for heavy metals such as benzene, toluene, mercury, lead, etc., are roughly 3 times as high as those laid out in the guidelines by international organizations such as the World Health Organization, European Commission, Organization for Economic Cooperation and Development, and the International Organization for Standardization. Furthermore, a gas bin does not cover things like the polyaromatic hydrocarbons or a number of toxic pollutants, aromatics, aliphatic, inorganic compounds, heavy metals, chlorinated aromatics, and persistent surfactants, which are known to be harmful to the environment. And for example, it only has 10 polyaromatic hydrocarbons when you compare that to the US, which has about 16 of them. So in light of the available information and international best practices, it is necessary to include a more comprehensive list of polyaromatic hydrocarbons, for example, which we've said it's actually very toxic to the environment. Now, to achieve stringency, the range of polyaromatic hydrocarbons in the gas bin standards needs to be increased. And it also needs to be amended to include a wider range of pollutants. Now, the second issue is compliance. The second key concern is the role of a single authority as the licensing and permitting authority for oil and gas operations, as well as the enforcement authority for environmental pollution. Now, balancing the objectives of achieving regulatory effectiveness in enforcing environmental standards while allowing for economic development is a non-trivial challenge which borders on potential conflict of interests. This concern is also reflected in the 2011 UNEP report, which concluded that there's clearly a conflict of interest in the ministry, which on one hand has to maximize revenue by increasing production, and on the other hand ensures environmental compliance. Ideally, Nigeria should adopt a dualist approach under which licensing of petroleum operations falls under the remit of a separate energy ministry, while enforcing environmental standards in the oil sector is within the purview of the National Environmental Agency. Another issue which needs some clarity is the legal status of a gas bin as a regulatory instrument in the Nigerian oil and gas sector. A gas bin is the Nigerian Regulatory Commission's guidelines for addressing oil-related pollution in the oil sector. Consequently, because it's not an act of the National Assembly, neither has it passed through an extensive legislative debate process. A gas bin remains purely a guidance document with no direct force of the law. Ideally, the oil sector pollution should be addressed by legally binding environmental legislation that stipulates standards, enforcement, and punitive measures for default. Given the plenitude of environmental challenges facing the Nigerian oil and gas oil sector, strict and rigorous environmental legislation with robust input from local stakeholders and communities is crucial. Now, the third issue is transparency. One of the biggest weaknesses of the gas bin is that it fails to provide a clear and robust opportunity for stakeholders to provide inputs and or intervene on project applications, even though it contains a requirement for the operator to identify and discuss the management and or implementation impacts with stakeholders. It does not clearly define who qualifies as a stakeholder. Neither does it provide clear guidance on the methods that interveners can use to provide input. The stakeholders engagement process goes beyond just discussing with stakeholders. It is a robust and participatory process that seeks to allow members of the affected public to take part and influence decision-making, which determines whether the project should be approved to proceed in light of the available information. In the UK and in the US, particularly North Dakota, all stakeholders are able to intervene in project application to challenge environmental impacts. Alberta and Norway adopt a much narrower threshold that allows those directly affected by the project to intervene. Furthermore, the lack of transparency in conducting joint investigations in which the oil companies are the primary investigators has been highlighted by the local and international stakeholders as a point of concern. As with the 2011 UNEP report, which notes government agencies are at the mercy of oil companies when it comes to conducting site inspections. That concern is re-echoed there. Another key weakness with the Gaspian, as well as the overall regulatory framework that we've experienced in Nigeria in the past decades, is that it does not provide any procedure for auditing the activities of the regulating agency. This leaves the question of who audits the regulator itself. And given the level of discretion that a Gaspian grants to the regulatory agency to provide certain discharge permits beyond the intervention values, it is important for the purposes of transparency to lay down procedures for auditing how this agency discharges its oversight functions. A transparency and accountability process for environmental regulation must provide a clear and independent process for auditing the regulator. For example, through the use of an independent ombudsperson for environment and sustainable development. This will enhance overall regulatory efficiency and reduce the propensity for conflicts of interest. Now, in conclusion, regulatory oversight in Nigeria, as we've seen, and as it even affects produced water or environmental sustainability, is not aligned with international best practices yet. We've made some headways, but we're not there. There are still aspects of transparency and accountability to improve on. Although the 2018, the Gaspian in principle seeks to adopt best practices using methods and guidelines that are consistent with international standards, transparency and accountability in interpretation and implementation remains key concerns. There is an urgent need to reform these Gaspian guidelines in line with the recommendations that have been provided, and even more that have been provided by other thought leaders, to make sure that the standards are rigorous and comprehensive in line with the international best practices. The call for this reform becomes even more important in view of the ongoing Nigerian petroleum industry reform sequel to the passage of the Petroleum Industry Act in August 2021 and the energy transition movement, which is currently ongoing, where our customers are demanding more cleaner and more responsible exploitation of energy, exploitation and consumption of energy. Thank you very much.
Thank you for that, Dr. Wisdom. Thank you for that presentation. Have we got any questions for Dr. Wisdom? Do we have any questions? I don't think so. So, Dr. Wisdom, thank you very much for your presentation once again. Thank you for taking the time to come out to be with us. I'm going to hand over to Lucy now, who's going to talk us through a few items before we go into networking.
Hi everyone, I'm Lucy Wakeford from Digital Leaders. I'm the virtual delivery partner for this event. And as you will have seen on arrival, this is quite a unique platform, so I'm just going to take you a few minutes to go through some virtual housekeeping with you. Right now we're in stage mode, where everyone in the room tunes into a presentation, a fireside chat, or a panel discussion. And in this mode, you're automatically on mute with your camera off. To the right of the stage mode, you can see 3 tabs. The first tab is chat. In there, you can see the general chat, which is a conversation with the whole room. Please do use that chat if you have any comments on the presentations, if you want to introduce yourself, or if you just want to put some emojis on in there, please do keep using it. It's a really nice way to interact. You also have the ability to search for attendees and send a private message, so please do this if you have any technical questions for me. The next tab is participants. That's all of the people currently in the room. You can see who they are in there and message them directly. And then finally, you have the Q&A, which I know a few of you have already been using. Ask questions for the presenters. So if you post a question there, other attendees will be able to vote, and the most popular questions go to the top. So please do keep posting and upvoting throughout the day. We're about to go into networking mode, which allows you to network and speak with other attendees and speakers, just like you would do in a real face-to-face conference. So that's the really exciting thing about this platform. When we navigate back, you'll see a room with lots of tables, and that will allow you to network and to speak with other attendees. So please turn your camera and your microphone on using the controls at the bottom of your screen. You'll be able to see who's at each table by hovering over the little circles, and to navigate to a specific table, you just need to double click on that table. Each table has a maximum number of attendees, either 2, 4, 6, or 8, and which is supposed to encourage productive conversation. So imagine it's just like a real event table and have fun. You'll also see that there are some sponsor banners around the sides of the room. These banners are clickable, so please do have a click around and explore the pop-ups. Last thing from me, you should see a little circle in the top right-hand corner of the screen. If you click on this, you'll be able to update your profile. So you can add a profile picture, add a headline, add a job title, and integrate your LinkedIn and website if you'd like to do that. This will help attendees know who you are and connect with you. As we all know, virtual events do come with their own unique set of glitches, so please don't worry, there are plenty of people around to help. If something isn't working quite right, just refresh the page. That usually sorts things out. And if you need any help at all throughout the event, please reach out to me in the private chat. And enjoy the experience. Have fun, get involved. Just remember, you can't break anything. And Dr. Wilson, do you want to say something before we go to networking? Okay, I think we'll go to networking now.